Well, good morning, good afternoon, everyone. My name is Jesse. I'm here with Exploring by the Seat of Your Pants, and so are all of you. We have so many kids joining today. It is ridiculous. We've literally got kids from California to Nova Scotia and Louisiana to the Northwest Territory. So we are like crossing all of North America in the most epic way possible. And for good reason, because we've got one of my favorite speakers of all time, who I'm just going to introduce in about a minute. Now, first, I want to note this is February. So this is our entire month solely dedicated to the most amazing women in science and exploration on planet Earth. By month's end, we will have done 55 broadcasts featuring cave divers, neuroscientists, astronaut trainers. It has been a wild ride. Everything's on our YouTube channel, as you may know, so you can check out this program and anything else you want to find out right there. It has honestly been one of the best months we've ever had. It's also exciting today because we're diving back in with an epic space program. Now, all this last week and a bit, we've been partnering with the folks at Western University's Institute for Earth and Space Exploration. They've been really integral to helping us bring all these amazing space programs for free to all of you. So I want to say a big shout out to them because it has been awesome. If you didn't catch Caitlin Crawford, NASA JPL as well, talking the other day about powering robots to the far edge of the solar system. We also talked with Cass Marion about training astronauts and discovering Mars in Canadian Arctic lands. It has been incredible. Again, all on our YouTube channel. So lots to explore and discover if you're keen on space. Now, I will note before I introduce our speaker, we have a Kahoot today. So if you want to play along with a little 4-question quiz between our talk and our Q&A, you can pull up that game pin and do just that in about 25 minutes or so. So stay tuned for that. Lots of fun to be had. Now, I'm so excited because we're bringing back in one of my all-time favorite speakers. There's like 3 people that I consistently list as like my favorite people we ever have on. I'm not going to say them all right now. You'll have to come back and join us. But Abby Fraeman is one of them. She is at NASA's Jet Propulsion Laboratory. She gets to work on robots that go explore other planets. It sounds like a fake job, but it's not. It's a real job that actual people can do. So Abby's here to blow our mind, take us on a journey exploring Mars together. Are you guys excited? I'm excited. Let's meet Abigail and dive in. Thank you so much for joining us again. It's honestly, it's such a pleasure to have you. You've got this great view. You've got like the California mountains today. It's just wonderful. It's lovely.
Oh, thank you. I'm so excited to be here.
Well, as I said, we've got a bazillion kids super excited to see you. So I'm going to zip my lip and leave you to take us away and blow our mind with what you get to do for a cool job.
Oh, fantastic. Well, hello, everybody. Thank you so much for joining me today. I am so honored to be part of this series and able to talk to you about my job, which is kind of sounds like a fake job, but it is a real job, and that is getting to explore Mars every day with rovers. So my name is Dr. Abigail Fraeman. I am talking to you today from the Jet Propulsion Laboratory, which is one of several NASA centers that's located all around the United States. There's a picture of the Jet Propulsion Laboratory, or as we like to call it, JPL. We're located in Pasadena, California. So I think right down the road from some of you. As I mentioned, we are one of several different parts of NASA. NASA isn't just one place, it's many different places, and each place kind of specializes in something different. Some parts of NASA specialize in training astronauts. That center is located in Texas. Some parts of NASA specialize in rocket launches. That's located in Florida. Over here in California at JPL, we specialize in robotic exploration of the solar system. So if it's someplace humans haven't been yet or can't go, we want to get you there. There's a picture of my office building where I'm sitting right now, but here's where my other office is, and that is on Mars. Mars is known as the red planet, which you can probably guess why after looking at this picture. And here's just some fun little facts about Mars. Here's a picture of our solar system, the 8 planets in our solar system. Mars is planet number 4 out of those 8, right next door to Earth. It's a little bit further from the sun than Earth, about 1.7 times further. partially because it's so far away. It's very, very cold on the surface. The surface gets down to minus 284 degrees Fahrenheit, or 280 degrees below zero. And if you like thinking in Celsius, that's 140 degrees below Celsius. So very cold place. Another reason Mars is so cold is because its atmosphere is very, very thin. It has an atmosphere, but it's made mostly of carbon dioxide, not oxygen like our Earth's atmosphere. And there's very little of it. So it'd be a pretty tough place to breathe if you tried to on Mars. You wouldn't be able to. Mars is also a lot smaller than Earth. You could fit about 6 Marses into one Earth. I think Mars is a really cool planet to study for one really big reason, because it can help us answer what I think is one of the most important questions that we can ask as humans, which is, are we alone? In our solar system so far, we only know of one of those 8 planets that has life, and that's Earth. That's our planet. But looking at Mars, we can see that there's hints that maybe it had all of the ingredients that we think life needed, maybe many billions of years in the past. Today, Mars is too cold and its surface is way too dry to support any kind of life, at least as we know it, that it exists on Earth. But we like to wonder, maybe sometime billions and billions of years ago, was Mars a very different place? Was it a warmer place? Did it have things life needed, like liquid water? And if so, was there once life on Mars? If we answered the question yes, that's going to tell us something very profound about how common life is in the universe. If we find it twice in our own solar system, that would be extraordinary. And I think it would make it very, very likely that there would be life in some of the thousands of other planets that we've been discovering around other stars. I also think Mars is a great place to study because it's hopefully some place that we as humans are going to get to visit one day. Mars, like Earth, it has a rocky surface. It's a place we can walk around. It's a place we could explore with human astronauts. You know, as I said, the atmosphere is very thin. You wouldn't be able to breathe. You'd need to wear a spacesuit to keep you warm, to keep you alive. But wouldn't it be fabulous if we could go there and explore the surface of Mars? Before we can do that, we need to understand the kind of challenges that astronauts might encounter before they get to Mars. What sorts of materials do they need to bring with them? What sorts of materials might they find on Mars that they can use? What are the environments going to be like that they're going to encounter? These are all really important questions that we must answer before we can send humans to explore Mars. To answer both of these questions, what are humans going to do? How can they survive on Mars? And is there life on Mars? Was there evidence there was life on Mars in the past? We can use the field of geology to learn this information. That is, we can look at the rocks and study the environments on Mars to learn what it was like in the past and what it's like today. Here's a picture of some of the things I get to do for my job, which is go to Mars-like places here on Earth to study the rocks, to learn about what the processes might be that affect these rocks that might be similar to what we're seeing on places on Mars. Some Mars-like places on Earth include places that you have volcanoes. So these are places like Hawaii or Iceland. Also places that are very, very dry. So places like the desert. Here's a picture of me in Utah in the southwest of the US. There's deserts in like Chile, Atacama, Chile that I'd love to go to. Those are very Mars-like. So I get to go to these places, look at the rocks, look at them in the context of what we might learn here on Earth to help us understand Mars. But as a geologist, you know, a lot of the things that I do involve walking around in the field. I have a rock hammer. I'll break open a rock. I'll look at it up close with my hand lens like I'm doing in that picture from Utah. Can't quite do that yet with the rocks on Mars because we haven't sent humans to that planet yet. So instead, we've sent a fleet of our robotic geologists. These are all different satellites and landers that we have sent from Earth to Mars to study its geology and its environment to learn more about this planet. Um, our first spacecraft were spent to Mars in the late 60s. And since that time, I think we have a pretty impressive array of explorers that have been able to go to the planet. And it's all different countries have sent explorers to visit Mars. We've had satellites from the United States, satellites from Europe, satellites from India and China and the United Arab Emirates. So it really is this global effort to try to explore Mars, to learn more about it. These satellites have taken just some fantastic pictures of the surface of Mars. Here's an example of a picture that one of the cameras on one of the satellites took of Mars. This is looking down. It's a little confusing, maybe, what you're looking at. If you stare at it a bit, I think you can probably see some layers in there. What we're seeing is layered rock. This is sedimentary rock that was put down by processes involving wind or water. And all of that stuff in between there that kind of looks like water, that's actually sand. Those are sand ripples on Mars. On Mars, the sand is actually black because it's made up of crushed up bits of volcanic rock. Here's another beautiful picture of that black Martian sand that we've been able to see from orbit. And we can look at pictures like this to understand more about the environments on Mars. It turns out if you take enough pictures of sand like this on Mars over many years and you line them up very carefully in some very special places, you can even see the sand dunes blowing across the surface. So even though Mars has a very thin atmosphere, you can still have blowing sands around the planet. Here's another picture taken from the orbiter, and you might think, gosh, those are some strange colors. I know Mars has black sand, but does it have green rocks? Does it have purple rocks? And the answer is no, not really. This is a special kind of data that we can collect from orbit that actually tells us things like the composition of the surface of Mars. It tells us the kind of rocks that are there on the surface. And in this particular image, we're using the different colors to represent the different types of rocks that are there. And in this particular case, this is an area called Jezero Crater, where we've landed one of our rovers to explore. And some of the rocks here are rocks that we know form in watery environments. There are salts, there are clays. And that's really interesting because it's helping us understand this question about, was there life on Mars? Mars is way too cold for liquid water today, but we know liquid water is one of the ingredients that life needs to survive. And because we can see images like this from orbit and we see rocks that only form in liquid water, this tells us that, well, maybe when these rocks were forming billions of years ago, maybe there was liquid water on the surface. And that means that there was at least one of the ingredients that we know life needs. And it means that Mars was probably a much warmer place a long time ago. It was warm enough that you could have liquid water on the surface to form all of these different kinds of rocks. But my favorite way to explore Mars is not from orbit, but from the ground. And here is just one of the fabulous pictures that we've taken with some of our landers and rovers on the surface of Mars. We're back to looking at Mars in the regular colors like you would see with your own eyeballs or your camera on your phone. And in this particular picture, you can see Mars is very red. Our first views of the surface of Mars came down. The first view ever was in 1976 from a mission called Viking 1. And there was another mission that followed up pretty quickly called Viking 2. And then it was another many years before we sent the next thing to land on Mars, which was the Pathfinder rover in 1997. I think one of the things that you can see in common of all of these pictures is they all kind of show a similar surface, and similar to that last picture that I just showed. All of these missions landed in places that were basically volcanic, broken up lava flows. And so you can see there's sort of these dark black rocks. They're kind of pointy. They've been sculpted by the wind. And then they're all covered by this very thin layer of dust that you find all over Mars, this very, very red dust. That's red because it has iron in it that has rusted. So that's what makes Mars red. It's this red, rusty dust that covers the surface of the planet. But for a long time, I think a lot of people thought that this is what Mars looked like. The entire planet was kind of this broken up volcanic place. It wasn't until about 20 years ago that I think our whole view changed. And it was nearly exactly 20 years ago, in January of 2004, that a pair of rovers landed on the surface of Mars named Spirit and Opportunity. And it was really one of these rovers, the Opportunity rover, that I think was the first thing to start to change our entire perception of the surface of Mars. Here is what Opportunity's first landing site looked like, and it's just spectacular. I think you can see right away that this looks very different from those other views of the surface. Here we have kind of dark sand, and then poking up off in the distance are these light-colored rocks that look very different than those volcanic rocks. And it turns out that these are actually a kind of rock called sedimentary rock. This was rock that formed in a basically is wind-blown sands that were cemented into rock when you had groundwater coming up and turning it into rock. And it just shows that Mars is this really diverse, wonderful place. In fact, it was this particular image that really made me want to do what I do today, which is get to explore Mars, because I think it really showed for the first time that Mars is a place worth exploring, that there is so much diversity to this planet, and there are so many places and different things that we haven't seen yet. Here's actually a picture of me seeing this picture for the first time. I was 16 years old when Opportunity landed. I was a junior in high school, and I actually got to come out to the Jet Propulsion Laboratory for an outreach program and be in the room with the scientists and the engineers when these pictures were coming down. And it just blew my mind. And it made me realize that there are people who have jobs where you get to look at pictures like this, and then you get to decide what to do with them. Where, if you had the rover, would you want to drive? What measurements would you want to make? What does this all mean about the history of Mars and the chance that the planet maybe once hosted life? Turns out if you make the decision to drive your rover over to those light colored rocks and take really close-up pictures, they look really cool. They're covered with these tiny little spheres. They're about the size of a tiny little bead. If you look up really close to these spheres, you can see that picture there on the right. They kind of look like little alien eggs, but they're not. They're actually a certain kind of mineral that is called hematite. And this is a mineral that forms in liquid water. So just like what we saw from orbit, we're seeing on the ground is these kinds of minerals that only form in liquid water. So it's once again telling us that Mars was once a very warm and wet place and may have been a place that life could have existed. I'll do a quick shout out. If you want to learn a lot more about Spirit and Opportunity, there's this wonderful documentary on Amazon Prime called Good Night, Oppie. So if you're interested in learning more, I highly recommend it. It's a great movie, good for all ages. Learn more about Spirit and Opportunity. But I'm going to jump ahead to what I get to spend most of my time working on now, and that's the Curiosity rover. So you can see here's a rover family portrait of all of our Mars rovers, starting with little Pathfinder, the first rover, to Opportunity, which is about the size of a grown-up human, all the way to Curiosity, which is kind of the size of a miniature car. And here's another picture of Curiosity using all of its science instruments. The rover has a laser on its head. It has a whole bunch of different cameras. And one of the really important instruments Curiosity has is a drill that we can use to drill into the rock and collect rock powder and then put that powder into instruments that are inside of Curiosity to analyze it really intensely, to learn a lot about its composition. And in particular, one of the things that we can look for is something called an organic molecule, basically any molecules that have carbon in them. And like liquid water, that is another ingredient that we know life needs. So I like to think of Curiosity as kind of a virtual robotic chemist with these instruments inside. And I do want to make sure to point out, for those of you calling in from Canada, one of the instruments on Curiosity's arm is a Canadian instrument. It has the very fancy sounding name of the Alpha Particle X-ray Spectrometer. But this is a really important instrument that we use almost every day. And we have a great portion of the Curiosity science team who calls in from Canada every day to help us operate the rover. Curiosity landed in a big old hole in the ground in Mars named Gale crater. This is a big hole that formed when a giant meteorite slammed into the surface of Mars. But the important part about this is not that it's a hole, but that it has a mountain in the middle of it. This is a mountain we call Mount Sharp. And from orbit, we could see the mountain was made of all different kinds of layers of rocks. And so we really wanted to study those rock layers to learn what different environments may have put them down. Here's a picture of Curiosity's site right after the rover landed on the floor next to this mountain. And you can see it looks like a pretty big mountain. It's about 3 miles high or 5 kilometers high. Immediately after Curiosity landed and looked down, we saw rocks that looked like these. And as geologists, we got very excited. They had all of these big round pebbles. And it turns out rocks like these are the kinds of rocks that you generally find in stream beds on Earth. If you have a lot of water that's moving very quickly, it can round those rocks, turn them into pebbles, and then put them into rocks that look like this, called a conglomerate. So this was our first sign of evidence that we'd landed in another place on Mars that once had liquid water. There was once a river where we landed. Looking ahead to the mountain, we were able to look at it with our telescopic camera, and we saw layers and layers and layers, which is very exciting because that's what we thought we would see from orbit, but we're now even starting to see more fine detail of those layers. And when we reached the base of the mountain, we saw that there were even more layers within the layers. So this is looking at a rock with our hand lens imager, just like I did as a geologist, getting really up close to the rock. And what you can see is an uncountable number of these very, very thin layers that are all parallel to each other. They're very fine grained. You don't see big pebbles like we saw in that river rock. So this is the kind of rock that would form in an environment where you had water, but it would have been much calmer, quieter water. It only suspended very fine particles. And that's something like a lake. So what we found is that Gale crater is actually once filled with a lake. You had rivers coming into the lake. And then as we've climbed the mountain, we found evidence that the rocks were still deposited in the lake. So the lake probably lasted for tens of millions of years. So not only did Mars once have liquid water, but it had liquid water that stuck around for a really long time. So this is telling us that Mars really could have been a place that you might have expected to find life, which is really exciting. And I think is further encouraging us to continue exploring Mars, continue looking. Is there any evidence that there was once life on Mars? And, it probably isn't going to be something like dinosaurs. It's probably going to be something like little microbes or little bacteria, very, very tiny life. But, if we brought some of that kind of life that we have on Earth into Gale crater about 3 billion years ago, it probably would have been very happy here. Right now, Curiosity is continuing to climb up the crater, and here's just a beautiful panoramic picture that we've taken. We've gotten pretty high on the crater, and you can see the layers continue, rocks of all different textures and colors that, again, reflect different environments that these rocks formed in. And just to tell you a little bit about what it's like commanding Curiosity, here's a picture of just some of the team members who help control the rover. On the top, you have some of the members of the engineering team who are all here at JPL. And on the bottom, you have members of the science team. And as you can see, it takes quite a lot of people to operate a rover. And we all have to work together every day to figure out what we want to do, what data we want to collect, where do we want to drive the rover, and then what does it all mean? My day typically starts off like it did about an hour and a half ago, looking at a scene just like this. In fact, this was the scene we were looking at from Curiosity. And that whole group of people gets together. We all get on the phone or the Zoom together, and we talk about which rock is interesting. Which one do we want to shoot the laser at? Is there a rock here that we might want to drill? Where do we want to drive next? And once we make those decisions, we work with the engineering team to figure out which of these activities can actually fit in the course of the Martian day. How much power do we have? How much data volume do we have available to downlink? And hopefully we put that all together into one beautiful plan. We spend the day kind of coding that up, writing lines and lines of code to send to the rover. And at the end of the day, we send that over to our command center here at JPL, where it then gets uplinked to Mars. And the rover does exactly what we hoped it would do. And then we come in the next day and we look and we see what happened. And then we have to start all over again, deciding what we want to do the next day. I'll wrap up by just showing you some great pictures from Curiosity. Here is one of my favorites. This is actually not just one picture, but a whole bunch of different pictures showing all of the different drill holes that Curiosity has collected. In fact, this morning, we just collected our 40th drill hole. So there's not quite 40 drill holes here, but you can still see quite a lot of them. And one of the things that I love about this image is it shows you that when you look beneath the dusty red surface of Mars, it's actually quite a colorful planet. It's not just the red planet, but it's the gray planet and the purple planet and the maroon planet and the brown planet. And all of these different colors, again, are from the different minerals in the rock that reflect the different conditions when the rock formed. Here's just another picture looking towards Mount Sharp with our telescopic camera. One of the things that really strikes me about Mars sometimes is how Earth-like it looks. You know, there's no plants or trees here, but other than that, we might as well be in the desert in the US Southwest or in other places, dry places in the world. It's incredible. And remember I told you that the sand on Mars was black? Hopefully you can see all of that black sand blowing up in here. In fact, we've seen a lot of black sand at Gale crater. Here's another picture taken from the rover. We're looking backwards to this giant black sand dune that we investigated, looking at the composition and the structures in the sand on Mars. Mars also has weather, even though the atmosphere is very thin. We can still see it blowing sometimes sand and a lot of times dust. So here's a feature called a dust devil that we've seen form on Mars. This one is tens of meters tall, blowing along the surface and telling us again more about the environment on Mars. Speaking of weather, Mars also has clouds sometimes. Here's a picture of certain kind of clouds that are called noctilucent clouds. That's a fancy name for clouds that come out when the sun starts to set and it causes the clouds to glow. Again, this is just a picture that makes Mars feel so much to me like a place and like an Earth-like place. I can imagine myself pitching my tent right next to that bunch of rock, looking up at the clouds as the stars start to come out in the evening. Clouds on Mars, like clouds on Earth, can be made of water, but they can also be made of condensed carbon dioxide if they get really, really cold. Another cool thing that we found with Curiosity are other things that fall from the sky, not just the rover, but meteorites. This is a meteorite that we found on the ground, a hunk of metal from space. This one was about the size of a football, so pretty big. And here's just one final picture from Curiosity. This is a false color image. Mars is not actually blue and yellow, but we took this picture actually with our black and white camera looking back towards where we've climbed up the mountain. One image was taken in the morning, one image was taken in the evening, and then we colorized them and put them together. And it just makes for, I think, a beautiful postcard from Mars. And it reminds me that not only is there a lot of interesting science that I get to do every day, exploring Mars, but there's also a lot of beauty. I think Mars is a beautiful place, and it's taught us a lot about other worlds and hopefully a little bit about ourselves. So I'll wrap up and let you know that you are always welcome to explore with us. We post images, we post updates every time we command the rover, and you can learn all sorts of information about Curiosity and NASA's other rover, Perseverance, at mars.nasa.gov. So thank you all so much for your attention, and I'm happy to take your questions.
Dr. Fraeman, that was, every time I get the chance to hang out with you, you've got more new pictures of Mars that are even more captivating, that do make it seem more like a place. And I think that's something that really is amazing. I mean, I grew up and I was like, oh, Mars, it's out there. And there are, color drawings of it and all this other stuff. And it's the fact that we have robots on there right now that are exploring and getting these images, that it's so special. It must be so amazing to get to wake up every day and be like, this is what I get to do. I get to look at the latest pictures and interpret them and share them with the public. It's just amazing. Well, I'm going to stop talking. We're going to go to our Kahoot first to see who is paying attention, have a little bit of fun. And what you win from this is Abby and I's everlasting respect. So that's worth quite a bit. It's always a lot of fun. And then we're going to do questions. Dr. Kiziar, our Milton Academy, we're heading to you guys first for questions. All our Del Sol Academy folks, Miss Barras, Miss Fairchild, everyone. Excited to see you guys all in a sec too. But let's start with our Kahoot together. And Abby, if you want to give us little hints for each of these, you're welcome to subtly guide the way. All right. There's a longer Kahoot on our Kahoot page if you want even more action when we're done. I'll link it into our classes. All right, Earth is the third planet from the sun. Mars is which one? We talked about this right at the very beginning. Is it the second, the fourth, the seventh, or the 11th planet? Do we even have 11 planets? I don't know. Maybe not. What do we think?
3, 4.
Might be it. That's pretty good. Yep, 60 answers. Wow, there's so many of you. So most of you got this right. It is the fourth planet. It speaks to the fact that we're able to go there, that we want to go there, is that it's close by to us. It's our neighbor. And our other neighbor is Venus. And Venus is a lot less, you can't drive around rovers on Venus's surface because they'll melt. So that makes it very tricky. All right. We got our first answer. Way to go, everyone. Rojo Gato Montes is in the lead as we go to question 2. It takes about 3 days to go to the moon. How long does it take to go to Mars? Is it 7 days, 7 weeks, 7 months, or 7 years? What do we think, classes? Is it just past the moon? Is it like twice as long as the moon? Seems short. No. 7 weeks? I mean, I don't know. No. Higher. Yeah. Let's see what we got. Almost 70 answers. 7 months is the correct answer. Ooh, big mix. A lot of you thought it was 7 days. No, Mars is way further away. It's such a different order of magnitude to get there. It's what makes it so challenging. It's what makes it such a triumph when we land robots there, and why we haven't sent people yet, because it's an entirely different experience. You can send people to the moon and back in a week. It would be like a multi-year journey to go to Mars with astronauts. So here we go. Let's see how that switches our thing. Oh, we got the same leader with Focused Alpaca second. All right, we're going to head to our Louisiana folks first in Q&A in just a minute. How big is Mars compared to the Earth? Is it a quarter the size, half the size, twice the size, or 4 times the size? Ooh, we had some pictures comparing this. In fact, one of our Kahoot pictures compared this. It's fine. You're a great hinter, Abby. This is great. All right, 77. There's almost 80 of you now. Ooh, a lot of you thought a quarter. So half the size. It is not. Yeah, here we are. I don't need to explain any more than that. We'll go to question B. Changed our leaderboard radically. Champion Gazelle takes our lead. True or false? We have multiple landers and rovers on Mars right now. This is the essence of our talk, so I hope you all get this right. The moon is smaller than Mars, so it's closer to what we had a minute ago. Yeah, a little thumbs up. That's the joy. That's what JPL is all about. We put these amazing, amazing things, and I'm going to do a plug again. Goodnight Oppie is amazing. Everyone should go watch this when you're done on Prime Video. Yes, we have multiple rovers and landers on Mars right now. We've got so many more missions planned. It is the best, most exciting time ever to be interested in space in human history ever. It is endlessly thrilling. All right, let's check our leaderboard. We're going to head Dr. Kaziar's class first. Red Bobcat is third. Champion Gazelle is second. And first, barely. The close run thing today, Nimble Horse. Way to go. If you are any of those folks, let us know who you are. And we're going to dive in with questions. So, Milton. Hello. Welcome in, middle school. Hi, guys.
Do you know what happened to Mars causing human life to not be possible?
So do I know what happened to Mars so a colony of human life is not possible? Was that the question?
Yes.
Yeah. So there's never been human life on Mars leading up to this. But yeah, why did Mars turn into such a place that we couldn't colonize it? Or if we did, we would certainly need to bring big domes with us, all of our water, things to breathe. And I think that actually is the key question and some of the reasons that we're so interested in studying Mars. Big picture, we think part of what might have happened is the fact that Mars is so small that it cooled off inside pretty quickly. And that means that the heat that would power convection in the core in the middle of the planet stopped, which means the planet lost its magnetic field, which is really important on Earth to shield the surface from radiation, but also kind of keep the atmosphere in. So when that gets lost, you start to strip away the atmosphere. And without an atmosphere, it's really hard to keep a planet toasty and warm. And so that may have played some role. But getting the details exactly about what happened and how it happened is something that we're really interested in continuing to study.
I'm so glad when we get questions like that because they sort of underscore how much how much sort of success we've had and how much there is to learn. It's tricky to sort of uncover why a planet changed that much in the last billion years. Like, I mean, we've just been studying this in the last few decades, really in a serious way. So thank you for that great question to kick us off, guys. Miss Vieira, I'm heading to you next, and then Miss Siegel. I know your mic probably still isn't working, so if you want to share in the chat, I'll pass along your questions to Abigail in a second. But Miss Vieira, third graders, hi, guys.
Hi. How does curiosity charge during the day?
Yes, great question.
Great question. Yeah. If you think about electronics, your computer, your cell phone, you usually plug that into the wall to charge, but there's no wall plugs on Mars to get energy from. So Curiosity is actually nuclear powered. There's a piece of plutonium in the back of Curiosity that generates its own heat as it decays. And we can use the heat from the plutonium to make energy. And that's how we power the battery that powers Curiosity. We've had other rovers in the past that instead of a radioactive source use solar panels. So Spirit and Opportunity had solar panels, and so they were able to charge the battery using the power of the sun. But it's kind of the ultimate in renewable energy when you're exploring other planets.
What a great question. Thanks, guys. Miss Siegel, I'll check in. I don't think your mic's working, but we'll say hi. Maybe kind of, sort of. Share in the chat. I'll take you guys in just a couple seconds, but we'll say hello while you're typing in the chat just so we get to see all you guys. Hi, everybody. I'm going to head to Miss Barra's class, and then we'll go to Miss Fairchild's right after that. Oxnard, hi, guys. Hello. All right.
Wow. Hi. This is probably the really obvious question, but are there really aliens in different planets?
Ooh.
Yeah, are there aliens? It's not an obvious question. The answer is we don't know. So we certainly haven't found any evidence for aliens yet. But that's one of the things we're looking for. We're looking if there were on Mars in the past. There are other places in our solar system we think there may be life, although we haven't found it yet. Places like the moons of Jupiter or Saturn, where we have oceans that are covered by a layer of ice. And of course, we're finding thousands of planets around other stars. And could there be life on those planets? we don't know, but it's certainly a comforting fact to think that Earth is not the only planet that has life. But so far, there's no evidence that there's life anywhere other than Earth. And I'll also note, I see a question from Mrs.
Yeah,
Siegel.
I'm going to take it. I'm going to get to everyone. I promise. I'm just making sure everyone gets their turn.
Okay.
But I love this question, and I'm so glad you answered it this way. It's worth noting for our kids that we pretty much think that there are as many planets out in the universe as there are grains of sand on all the beaches of the world. So it's pretty unlikely we're the only one that has life, but we are only able to probe so far. So we've only explored a few places directly. We're sending missions to explore some of these moons of Jupiter and Saturn that Abigail mentioned, but we're just barely scratching the surface of trying to look for alien life in the universe. And frankly, there's a lot of space out there. Space is really, really big. It's unfathomably big to think about how big just our solar system is, much less to the next star, to the next galaxy, and beyond. So I love when we get that question. Thanks, guys. All right, Miss Fairchild, I'm coming to you. I'm going to take the one from YouTube and the chat in just a second. Let's bring you guys in live. Hi, third graders. Welcome in. Unmute. Hello. I think your audio is off too, which is a bummer. So we have you. We'll say hi. So nice to have you guys in. Del Sol, there's so many of you today. But share in the chat, and what we'll do is we'll take your question in just a sec, and I'll share our one from Miss Siegel's class. How did the rovers get to Mars, Abigail? How are they hopping a ride, hitchhiking, getting a bus? What's the deal?
Yeah, it'd be fun to get a hitchhiking rover. But no, actually what we did was we built the rovers, then we packaged them all up, and then we put them on the top of a really big rocket. The rocket that Curiosity launched on was called an Atlas V, and launched it off the coast of Florida. And yeah, it took about 7 months to get to Mars from there.
Very, very cool. All right. I'm going to take one from YouTube while we're waiting for Miss Fairchild's class to type in the chat. Our folks in Yellowknife, welcome in Yellowknife, one of the coolest places on planet Earth. Everyone should go to Yellowknife. Dr. Fraeman, they have a student with a question. How many types of rocks are there on Mars? Miss Sampson's class.
Oh, great question. I don't know how many types. We're certainly always finding new types. I think the extraordinary thing is that the types of rocks that we find on Mars are the same as the types of rocks we find on Earth. Most of them are volcanic rocks, and you can get different minerals in these different types of volcanic rocks. You can break them up and make new rocks. And that's kind of these lake and wind deposited rocks that we've seen, but probably a couple hundreds of different types on Mars. And I have to add, I'm so glad to hear you're calling in from Yellowknife. We actually named some of the sites at Gale Crater after Yellowknife. Yellowknife Bay was one of the first areas we visited and found our first evidence of lakes. So it's a really important site for the mission.
How about that? How neat. Way to go, guys. Alyssa, who is presumably on camera. Hi, Alyssa. They want to know, how is there water on Mars? So what's the deal? Or how was there water on Mars? Anywhere you want to take this question?
Yeah. So today, there actually is some water on Mars, but it's not liquid. There's some water that is frozen as ice in the polar caps or right underground near the poles of Mars. There's some water that is gas, which is in the atmosphere, water vapor that forms those clouds that I was showing. But we think there was liquid water, which is what life needs on Mars billions of years ago when the planet was much warmer. And that would have been in rivers or in lakes or also in groundwater. So water right under the surface that occasionally would come up. People wonder if there's groundwater still today. Is there liquid water below the surface? We haven't found any evidence for it yet, but we are looking.
Abigail, this has been so much fun, and it's been so much fun that time flies when you're having this much fun. So we're nearing the end of the broadcast. So I want to just note, I know our classes have more questions. So if you have more Mars questions, email us. We will get you the answer. So please, you all have our email address. We'd love to get you more. I know some of you have to go in a minute, so I will encourage you. Mars.nasa.gov. It's the best site ever. You can follow along with an actual robot on an actual other planet and see pictures and learn about it and everything. It's amazing. I'm going to email that to all your teachers in just a minute, as well as a really great longer Kahoot that I got the chance to do with Abigail not too long ago. So you can check out even more, answer some more fun questions, and check this out and share with your friends on YouTube. It's all over the place. There's lots of Mars questions. I'm so excited. I'm smacking the mic away. This is a good problem to have. Is there any final message about Mars exploration? Anything you want to leave us with before I bring in all our classes to say thank you and farewell, Abigail?
Oh, just want to thank you all so much for your time. And I hope you're as excited about Mars as I am. And as always, you can follow along. You can see pictures from Mars as they come down the same time I see them. And so we're really eager to have everyone join us in this amazing exploration.
There's no better message than that. I hope all our classes take up that opportunity. I'm going to send you guys some great stuff in just a minute. But as you know, what we're going to do to wrap up every broadcast, Dr. Kizyard's class, Miss Fiera, Miss Siegel, Miss Fairchild, Mr. Ross, thank you so much for your time. Have a wonderful day.